It is widely known within the fiber optic industry that defects and scratches on fiber optic connector end faces negatively impact network performance. As bandwidth requirements continue to grow and each fiber carries more signals, verifying cleanliness of optical connectors becomes even more important. If dirty and damaged end faces are not inspected and cleaned systematically in both manufacturing and installation, the defects can significantly degrade network performance. Some reports suggest that at least 50% of network outages are caused by contaminated optical connections. In order to guarantee a common level of performance, the International Electrotechnical Commission IEC has created a standard 61300-3-35 to specify pass-fail requirements for the fiber end face inspection. Human inspection processes are becoming less attractive since they are highly variable and hard to validate full IEC compliance. In addition, inspectors' training, eyesight, ambient lighting, and display conditions further complicate manual inspection, reliability, and repeatability. Automation of the systematic inspection process using the FastMT programmed to the IEC or IPC standards eliminates the variables associated with manual inspection. FastMT provides a 100% repeatable, reliable, and quantitative process for end-face inspection to the IEC or IPC pass-fail standards. FastMT's unique optics and software automatically display from 4 to 72 fiber end faces for all regions of the MT ferrule without operator action to scroll to individual fibers. Currently available fixtures include UPC and APC MTP, the UPC and APC MT, the Prism Light Turn, and the MIL 38999. FiberQA will also custom design fixtures to meet your specifications. The FastMT 400 is capable of detecting particles with diameters less than half a micron and scratches as low as 0.3 a micron wide. The FastMT 400 shown here has a total inspection area of 2 inches by 2 inches. Models that test a single ferrule only are available in both 200 and 400X. To begin, an operator attaches a fixture, in this case, an MTP. All fixtures are keyed for accurate location and angle. The operator secures it in place on the scope with 2 side-mounted screws. Some models use magnets for even easier fixture changes. The fixture uses a zero insertion force design to ease the use for elimination of wear on both the part under test and the fixture. Once the part has been inserted, the operator executes a fine autofocus, fast and accurate focusing without operator judgment. Repeatable and accurate autofocus is one of the keys to FastMT's outstanding repeatability. To fully automate the focus, capture, and process operations, the operator clicks the Process button. For this MT12 ferrule, the FastMT 400 captures 4 columns of fibers at a time. In this case, 3 wide-field view images are acquired to capture all 12 fibers. The FastMT is capable to handle up to 72 fibers on the ferrule. The FastMT software locates and segments individual fibers into a grid of images for viewing all fibers simultaneously, maximizing the use of the graphics display area. The automated inspection utilizes multiple processing engines for fast, accurate, and quantitative results, about 24 seconds for a 12 fiber and 55 seconds for 72 fibers. Once the acquisition and processing is complete, all 12 fibers are shown, along with pass-fail results, defects, part, and metrology information. You may select an individual fiber for a more detailed review. The software utilizes an overlay feature to view the defects and metrology results from the processing. There is particle, scratch, rule results, metrology, and timing information on the tabs. Details on a specific defect can be viewed in the tables or below the image by clicking on the defect. You can also review the results of the IEC and IPC pass-fail specifications in the Rules tab. The software has been refined using images compiled from hundreds of millions of multimode MT fibers across many systems for the last decade and achieved pass-fail reproducibility of about 1 in a million. The FastMT also has an enhance feature, which increases the image contrast to help human operators see faint defects. Human inspectors will more reliably detect defects, especially very faint ones, with this enhancement enabled. There's nothing as genuine as a real-time demonstration, so let's watch the entire process for a 12-fiber MTP. Eliminate human subjectivity from inspection with a fast, automated, repeatable system for high-density fiber end-face inspection. Trust your inspection to FastMT for the highest IEC and IPC standard compliance throughout your fiber optic product's lifecycle. Achieve the promise of next-generation networks with true stability and performance.